So good morning. Got a snowy day here in Kentucky. We're going to continue working with equations of lines, and specifically we're going to focus on determining the slope of a linear equation. As we've talked about, slope is this steepness of a line. It also can be defined by a formula, y2 minus y1 over x2 minus x1. I can use this formula if I have been given 2 points. Don't forget also, we have this concept of rise over run, that change in y over the change in x. So it kind of describes the steepness of a line. And we've talked about positive and negative slopes. We've talked about zero slopes and no slopes. So, and most of that came from, we gave you a graph. Now we're going to turn around and actually give you an equation and see if we can determine the slope of a line. Well, let's start out with just what we know. If I give you an equation that looks like this, we know it's called a linear equation. And I can find the solutions to that equation by identifying ordered pairs, identifying points. So what we've learned is I can identify 3 solutions to graph the line. And when it's in this form, we know what we do is pick just values for x and we solve for y. So I can pick x to be 0. That's always a good choice. And I have then y equals 2 times 0 plus 4. So y would equal then 0 plus 4. Therefore y would equal then 4. So if x is 0, y has to be 4 to make that a true statement. So that's an ordered pair. We also know that since there's no fractions or decimals over here, it's not a bad idea just to stay with whole numbers. And let's just choose 1 for x to keep the math simple for ourselves. So y is going to equal then 2 times 1 plus 4. Y is going to equal 2 times 1 is 2. 2 plus 4 is, so it's going to be y equals 6. So we have 1 went in, 6 was my corresponding value. Okay? And again, we said it just takes 2 points to graph, it takes 3 solutions to graph a line, but since we're determining the slope of a line, we know slope really only requires 2 points. So I'm actually going to just graph this line with 2 ordered pairs. So 0, 4 would be located here, and 1, 6 would be located at this spot. And so what I can do then is I can draw a line through those 2 points. So kind of slipped on me a little bit there. So we have a line, and remember the slope describes the steepness of the line, and as we know that if I go from left to right, since this graph is increasing, we know that's going to be a positive slope. What we can also pick up on is just this rise over run. So from this bottom point, notice how it's going to rise up 2, and it's going to run over 1. So my slope is going to be a rise of 2 and a run of 1. So my slope from the graph is going to be a 2 over 1, which simplifies down to a positive 2. And again, that makes sense because it is an increasing slope. I should have a positive value there. So from the graph, I can determine the slope. We also have 2 ordered pairs. I have this 0, 4, and this 1, 6. So I can call this point 1, x1, y1. I can call this point 2, x2, y2. So using my slope formula, I could determine the slope of this line. So y2 minus y1, so that's going to be 6 minus 4. And then I have x2 minus x1. So x2 minus x1, that's going to be 1 minus 0. And I do get 2 over 1, which does simplify down to be a 2. So the slope of my line is 2. Now what's interesting in our equation is, notice how this equation is solved for y, and notice the coefficient in front of x there. coefficient of x is this 2. We found that the slope was 2 and that coefficient of x is 2. That seems to be highly probable that we may not even have to do this math. If I have an equation in this form here, I'm able to identify the slope by recognizing what the coefficient of x is. So what we're going to be picking up on is the coefficient in front of x is probably going to be our slope. And another thing is we pick up on is this b. Notice that when we plotted 0, 4, 0, 4 was what we call a y-intercept. That's where the graph crossed the y-axis. Notice that the constant here is a 4. So that 4 is an indicator that that very well could be what we call the y-intercept. So we're picking up on a few things here. This is considered the slope-intercept form. And therefore, our slope is a 2, and our y-intercept is a 4. So, a lot of times m can stand for slope. The letter b in linear equations, the letter b is denoted as the y-intercept. So, we have that information going on. So, as we move through this, if I give you linear equations, it may not be necessary to make a table. We may be able to go straight to the graph if need be. So let's see how that plays out. We'll do a few more examples and see if we can make sense of this. So stay tuned for more.